Hi, we are going to talk about implicit differentiation. There's an assumption for this lesson that you're already familiar with that. If you're not, you're going to have to watch another video because we're going to go a little bit faster without breaking it all down. So we're trying to find this derivative. Remember, you differentiate x regularly, and anything with y you differentiate. When you differentiate it, you're going to get dy over dx. So take derivative of 2 sine x, that's 2 cosine x. Derivative of cosine is going to be negative sine y times dy over dx, and the derivative of 2x is going to give us 2. So anything with dy over dx stays here. We're going to, well, we can rewrite it as follows. We can rewrite that sine y dy over dx is going to equal to 2 cosine x minus 2, and then dy over dx is going to give us 2 cosine x minus 2 divided, oops, I forgot sine y. It is going to be, oh no, I did not. I am doing fine. It equals, or divided by sine y, this is going to be our derivative. Okay, I apologize. Okay, so for the next one, we need to find the derivative of tangent y plus 2y squared equals 2x cubed. Derivative of tangent is secant squared y times dy over dx. Derivative of 2y squared is going to be 4y times dy over dx. Derivative of 2x cubed is going to give us 6x squared. So we can factor out dy over dx here, which is going to leave us with secant squared y plus 4y equals 6x squared. And we divide both sides, so dy over dx is going to equal 6x squared all over secant squared x y plus 4y. This is our derivative here. Okay, so our next lesson, our next problem is going to be, there's one more, and this one's going to be a little bit more involved. So in this problem we are going to look for the derivative, which is going to be our first task, and then I will tell you what we're going to do next. So this is our function. We are going to find its derivative here first, dy over dx. So 4y, the derivative of 4y is going to be 4 times dy over dx minus 3x squared equals 2y dy over dx minus 3. The terms with dy over dx come on one side, so we're going to get 4 dy over dx minus 2y dy over dx equals 3x squared minus 3, and then dy over dx, when we factor it out here and divide, is going to be 3x squared minus 3 divided by 4 minus 2y. So the next question here is, find all points where the graph is going to have horizontal tangent line. That means horizontal tangent line, we want dy over dx equals 0, right? And in this case we want to make sure that the numerator is 0 and the denominator is not, right? So we're going to set 3x squared minus 3 equals 0, which is going to give us x squared minus 1 equals 0, which gives us x equals plus or minus 1. So for each of these values we're going to need to find the value of y, and then we need to check that those values of y are not going to give us 0, right? Because remember, we need to find points, and in this case with the implicit function it's going to have to be x and y. So when x is, let's start with 1. When x is 1, we are taking this value of 1, we substitute that into our function. That's going to give us 4y minus 1 equals y squared minus 3, which is going to give us this quadratic equation, y squared minus 4y minus 2 equals 0. And when we solve this, you're going to have to use the quadratic formula here. We're going to get y equals 2 plus or minus square root of 6. So when y is 2 plus or minus square root of 6, the denominator here is not going to equal 0. So you already have 2 points, 1, 2 plus square root of 6, and 1, 2 minus square root of 6. Okay? For the second value, x equals -1. Let's find out what happens here. When you substitute that, you're going to get 4y plus 1 equals y squared plus 3. When you solve the quadratic equation is going to be y squared minus 4y plus 2 equals 0, which is going to give you the values of y. Y is going to be 2 plus or minus square root of 2. You are going to need to use the quadratic formula here as well. And you're going to get 2 more points, -1, 2 plus square root of 2, and -1, 2 minus square root of 2. Okay? So this is how these types of problems are done. We do have a few more questions regarding this problem. We have to find any points where the graph has vertical tangent lines. So vertical tangent line means the function dy over dx is undefined. Okay, so when dy over dx is undefined, you are going to have to set the denominator in this case equals 0. So you want 4 from derivative 4 minus 2y equals 0, which means y equals 2. And we substitute that into our function. So you get 8 minus x cubed equals 4 minus 3x. And this is going to give you a cubic equation. And in this case, I'm going to use a calculator to solve it. Your answer is going to be 2.196. I got that with a calculator. It's not exactly an equation that can be easily solved. All right. So the last part here is find the second derivative. So when we find the second derivative, we're going to differentiate this. So it's going to be 6x times 4 minus 2y minus 3x squared minus 3 times -2 times dy over dx. We're using a quotient rule here. All over 4 minus y, 2y squared. So dy over dx will be replaced with what dy over dx is. So in this case it's going, and we can start distributing over here. Well, actually I may hold on that. 6x times 4 minus 2y minus 3, I can put here minus 2 times 3x squared minus 3 times 3x squared minus 3 divided by 4 minus 2y all over 4 minus 2y squared. Okay. To get rid of that complex fraction, we are going to multiply the top and the bottom by 4 minus 2y. Right? So what that's going to give you, once you do the algebra here, it's going to give you 6x times 4 minus 2y squared plus, it's going to be, hold on, we're supposed to have a plus here. I forgot this because you got negative and negative. That's going to be plus 2, so plus 2 times 3x squared minus 3 squared. This will cancel here. That's how this you get squared divided by 4 minus 2y squared. Okay, this can be simplified a little bit more with some algebra, but we're going to leave it here this way because that would be sufficient for what we're trying to do right now, and we're not going to make it any simpler than this.